The morning of November 24th, 1944, Captain Robert Morgan guided his B-29 superfortress through scattered clouds at 30,000 feet, the Japanese coastline materializing through the haze below. Beside him in the cockpit of Dauntless Dottie, 110 other silver bombers stretched across the sky in formation, their polished aluminum skins catching the pale sunlight. This was Operation San Antonio I, the first American bombing raid on Tokyo since the Doolittle mission 30 months earlier. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed, because tomorrow I've saved something extra special for you. Morgan had flown 25 missions over Europe in the Memphis Belle, surviving German fighters and flak that could tear a fortress apart in seconds. But this felt different. The B-29 beneath his hands represented something unprecedented, a machine so advanced that its development had cost more than the Manhattan Project that would later produce atomic weapons. 4 Wright R 3,350 engines, each generating 2,200 horsepower. A pressurized cabin that allowed the crew to breathe comfortably at altitudes where Japanese fighters gasped for air. Remote-controlled gun turrets guided by a central fire control computer that could track multiple targets simultaneously. But in Tokyo, Japanese intelligence officers watched the approaching formation with calculations that told them a different story. Their estimates, compiled over months of careful analysis, predicted that America might eventually field perhaps 300 B-29 seconds capable of reaching Japanese cities, 300 bombers. That was the number their planners believed represented the absolute maximum production capacity that American industry could sustain for such a complex aircraft. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The B-29 project had begun in 1939 as a theoretical exercise, an attempt to design a bomber that could carry significant payloads across oceanic distances. At the time, the largest American bomber in production was the B-17 Flying Fortress, a 4-engine aircraft with a combat radius of roughly 800 miles. The Air Corps wanted something with twice that range, capable of striking targets 2,000 miles from its base and returning. More critically, they wanted an aircraft that could operate at altitudes beyond the effective ceiling of enemy fighters and anti-aircraft weapons. Boeing's design team, led by Chief Engineer Edward Curtis Wells, produced specifications that pushed every boundary of contemporary aviation technology. The aircraft would weigh 65,000 pounds empty, more than twice the weight of a B-17. Its wingspan would stretch 141 feet. The pressurized crew compartments would maintain sea-level atmospheric conditions while the aircraft flew at 35,000 feet. 4 massive engines would be required, each more powerful than anything currently in production. The Wright Aeronautical Corporation developed the R-3350 duplex Cyclone specifically for the B-29, an 18-cylinder radial engine that promised 2,200 horsepower from each unit. But the engine design incorporated technology so new that reliability problems plagued the program from its inception. The cylinders ran hot under sustained power settings, causing oil to overheat and ignite. Early test flights frequently ended with engine fires that could not be extinguished, forcing crews to bail out over test ranges in Kansas and Washington. On February 18, 1943, Boeing's chief test pilot Eddie Allen was conducting an evaluation flight of the second XB-29 prototype near Seattle when an engine fire erupted in the No. 1 nacelle. Allen immediately turned back toward Boeing Field, but the fire burned through the wing spar before he could reach the runway. The massive bomber plunged into the Fry meat packing plant 3 miles from the field, killing all 11 men aboard the aircraft and 18 workers in the building. The crash threatened to derail the entire B-29 program, but by that point, the Army Air Forces had already committed to production on a scale that made cancellation politically and strategically impossible. 1,664 B-29 seconds had been ordered before the first prototype ever flew, a procurement strategy that reflected both the desperate urgency of the war effort and confidence that American engineering could solve whatever problems emerged during development. The crash investigation revealed that inadequate fire suppression systems and poor engine cooling contributed to the catastrophe, leading to immediate design modifications across the production fleet. Japanese intelligence analysts studying captured documents and interrogation reports from American prisoners understood that the B-29 represented a significant technological achievement. They knew the aircraft incorporated pressurized crew compartments, remote gun turrets, and sophisticated radar systems. What they failed to grasp was the scale at which American industry intended to produce these complex machines. Traditional Japanese aircraft manufacturing followed European models that emphasized craftsmanship and individual quality control. Each bomber required thousands of man-hours from skilled workers who fabricated components to exact specifications. When Japanese planners calculated American B-29 production capacity, they applied their own industrial experience to estimate how many such aircraft the United States could realistically manufacture, while simultaneously producing fighters, transports, and naval aircraft. Their analysis suggested that America might eventually deploy 300 B-29s to the Pacific theater. This estimate assumed that American factories would follow conventional production methods, with each aircraft requiring extensive individual assembly and quality control. 300 bombers seemed like a reasonable upper limit for what any industrial economy could sustain, particularly given the B-29's unprecedented complexity and the engine reliability problems that Japanese intelligence had identified through signals, intercepts, and prisoner interrogations. The first production B-29s began rolling off assembly lines in July 1943 from Boeing's facility in Wichita, Kansas. The plant sprawled across hundreds of acres of prairie, with production hangars large enough to accommodate multiple aircraft simultaneously. Boeing had pioneered mass production techniques in the aircraft industry during the 1930s with the B-17, but the B-29 required entirely new approaches to manufacturing coordination and quality control. The bomber incorporated more than 40,000 individual parts, 600,000 rivets, and 9 miles of electrical wiring in each airframe. Traditional sequential assembly would have required building each aircraft from keel to tail over periods measured in months. Boeing's production engineers developed a system they called multi-lining, which broke the manufacturing process into parallel production streams that converged at final assembly points. Major sub-assemblies rolled off separate production lines simultaneously. Wing sections complete with fuel tanks and engine mounts, fuselage sections with internal structure and wiring harnesses already installed, bomb bay assemblies, tail sections. Each component arrived at the final assembly area as a complete unit, ready to be joined to adjacent sections through standardized mounting points that required minimal custom fitting. The system worked because Boeing imposed unprecedented standardization across the production fleet. Parts manufactured for one B-29 had to fit any other B-29 without modification. This interchangeability eliminated the custom fitting that traditional aircraft construction required, allowing assembly workers with relatively limited experience to join major sections using documented procedures rather than relying on individual craftsman judgment. But even with these innovations, early production rates disappointed Army Air Force's planners who had committed to deploying B-29s against Japan by mid-1944. The Wichita plant delivered its first production aircraft in March 1944, nearly 2 years after the initial prototype flight. By July, only 15 of the first 100 B-29s delivered were actually airworthy. Engine problems persisted despite continuous modifications. Electrical systems failed under operational conditions. Fuel leaks plagued the long-range tanks. Pressurization systems couldn't maintain seal integrity. General Henry Hap Arnold, commanding general of the Army Air Forces, intervened, personally, to resolve the crisis. In what became known as the Battle of Kansas, Arnold ordered production personnel from the factories deployed directly to modification centers, where aircraft sat awaiting fixes. Engineers and technicians worked around the clock for 5 weeks between March 10th and April 15th, 1944, modifying 150 aircraft to combat-ready status. The effort succeeded, but it revealed how close the B-29 program had come to complete failure. The Japanese military began detecting B-29 deployment to Asia during the spring of 1944, when reconnaissance aircraft photographed construction activity at airfields in India and China. Intelligence analysts correctly deduced that these facilities were being prepared for long-range bomber operations against Japanese targets. The Imperial Army and Navy began transferring fighter units from frontline theaters back to the home islands, anticipating that American bombers would soon attempt to strike Japanese industrial facilities. By June 1944, 3 air defense divisions had been established in the home islands with approximately 375 fighters assigned to intercept missions. Additional anti-aircraft batteries and searchlight units protected major cities and military installations. Japanese planners calculated that if American B-29 production reached the estimated 300 aircraft, perhaps half would be operationally available at any given time for missions against Japan. Defending against raids of 75 to 100 bombers seemed challenging but manageable, with the forces being assembled. The first B-29 raid on Japan occurred on the night of June 15 to 16, 1944, when 75 superfortresses launched from bases near Chengdu, China, to attack the Imperial Iron and Steel Works at Yawata in northern Kyushu. The raid caused minimal damage, with only 1 bomb actually landing within the target complex. But the psychological impact on Japanese civilians was profound. American bombers had reached the home islands, demonstrating that Japan's defensive perimeter had been penetrated. Japanese intelligence officers studied the Yawata raid carefully, analyzing bomber formations, altitude profiles, and defensive tactics. They noted that only 75 aircraft had participated, consistent with their estimates that American B-29 strength in theater remained limited. Follow-up raids throughout the summer reinforced this assessment. Individual missions rarely exceeded 100 sorties, suggesting that American production had not yet reached the maximum 300 aircraft that Japanese planners anticipated. What Japanese analysts failed to detect was the massive expansion of B-29 production facilities occurring across the United States during 1943 and 1944. Boeing's Wichita plant represented just one element of a manufacturing network that would eventually include facilities in Renton, Washington, operated by Boeing, Marietta, Georgia, operated by Bell Aircraft, and Omaha, Nebraska, operated by the Glenn L. Martin Company. The Bell plant in Marietta covered nearly 4 million square feet of manufacturing space, making it the largest dedicated B-29 production facility in the world. Construction began in 1942 on former farmland northwest of Atlanta, with the Army Corps of Engineers building hangars, assembly areas, and supporting infrastructure on a scale unprecedented in the aviation industry. By early 1944, 28,000 workers operated production lines that could accommodate multiple aircraft in various stages of assembly simultaneously. Martin's Omaha facility occupied 1.2 million square feet and employed 14,500 workers at its peak. The plant had originally been built to produce B-26 Marauder medium bombers, but was converted to B-29 production in April 1943 when strategic planning shifted focus to the Pacific War. Boeing's Renton plant, located on the shores of Lake Washington near Seattle, added another major production node to the network. Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel, it means a lot to us. Now, back to the story. Each facility operated on production schedules coordinated by the Army Air Forces to ensure steady delivery of aircraft to operational units. By late 1944, the combined output from all 4 plants approached 100 B-29 seconds per month. Boeing's Wichita facility alone had reduced the man-hours required to produce each aircraft from 157,000 for the first production batches to fewer than 20,000 by the end of 1944. The plant operated around the clock with multiple shifts, producing more than 4 B-29 seconds per working day at peak efficiency. The workforce assembling these bombers represented a fundamental transformation in American industrial labor. Traditional aircraft manufacturing had relied on skilled craftsmen with years of specialized training. B-29 production opened these jobs to workers with no aviation experience whatsoever, farmers from Kansas and Iowa, factory workers from Detroit's automobile plants, women who had never worked outside their homes before Pearl Harbor. The Marietta plant employed a workforce that was 37% female by 1944, with women operating rivet guns that weighed 15 pounds and handling sheet metal fabrication that required precision measured in thousandths of an inch. Training programs compressed skills that would traditionally require years of apprenticeship into weeks of intensive instruction. Workers learned to read blueprints, operate specialized tools, and follow standardized assembly procedures documented in technical manuals. The key was eliminating the judgment calls that traditional craftsmanship required. Every rivet hole was pre-drilled at exact locations specified in engineering drawings. Every wire connection followed color-coded routing charts. Every structural joint used fasteners of standardized sizes that eliminated the need for custom fitting. The Japanese never detected this industrial mobilization. Their intelligence network in the United States had been effectively dismantled after Pearl Harbor, leaving them dependent on signals intelligence, prisoner interrogations, and aerial reconnaissance to assess American production capacity. None of these sources could observe activities occurring deep within the continental United States, hundreds of miles from any coastline that Japanese reconnaissance aircraft could approach. In October 1944, the first B-29 seconds arrived at newly constructed airfields in the Mariana Islands. Saipan, Tinian, and Guam had fallen to American forces during the summer, providing bases less than 1,500 miles from Tokyo. Unlike the China-India theater, where every gallon of fuel and every bomb had to be flown over the Himalayas at tremendous logistical cost, the Marianas offered direct supply lines from American ports and manufacturing centers. Brigadier General Haywood Hansell arrived on Saipan on October 12th to establish headquarters for the XXI Bomber Command. The construction effort transforming these Pacific islands into B-29 bases operated on a scale that dwarfed anything Japanese planners had anticipated. Runways 8,500 feet long and 200 feet wide stretched across terrain that had been jungle or volcanic rock just months earlier. Taxiways, hardstands, and maintenance facilities accommodated hundreds of aircraft. Fuel storage tanks held millions of gallons of aviation gasoline. Ammunition bunkers stored thousands of tons of bombs in climate-controlled conditions. The 73rd Bombardment Wing, commanded by Brigadier General Emmett O'Donnell, deployed to Saipan with 4 bomb groups: the 497th, 498th, 499th, and 500th. Each group operated approximately 45 B-29 seconds, giving the wing a total strength of roughly 180 aircraft. But this represented only the initial deployment. 3 additional wings were already in training stateside, scheduled to arrive in the Marianas throughout the winter and spring. Japanese intelligence detected this build-up through aerial reconnaissance missions flown from Iwo Jima, an island roughly halfway between the Marianas and Japan that remained under imperial control. Reconnaissance photographs clearly showed the massive construction effort on Saipan and Tinian. Japanese analysts correctly predicted that large-scale B-29 operations from the Marianas would commence by late October or early November 1944. What they could not accurately estimate was how many B-29 seconds would ultimately be, based in the Marianas. The infrastructure being constructed suggested facilities capable of supporting several hundred aircraft, but Japanese planners assumed this represented redundancy and dispersal to protect against attack rather than indication of the actual force size that would be deployed. Their working estimate remained that America would field approximately 300 B-29 seconds total, with perhaps 200 based in the Marianas and the remainder operating from China and India. The reality unfolding across the Pacific bore no resemblance to these calculations. By December 1944, American factories had delivered more than 700 B-29 seconds to operational units. Production was accelerating rather than plateauing, with monthly delivery rates climbing toward 100 aircraft per month. The 73rd Wing's initial deployment to the Marianas represented merely the vanguard of a force that would eventually number over 1,000 bombers operating from bases that treated the Pacific Ocean as an American lake, rather than contested waters. The first major raid from the Marianas targeted Tokyo on November 24, 1944. 111 B-29 seconds launched from Saipan, with Brigadier General O'Donnell personally leading the mission in dauntless Doti. Weather over the target forced most aircraft to bomb alternative targets, with only 24 bombers actually attacking the primary objective at the Musashino aircraft plant. Japanese fighters intercepted the formation, but only one B-29 was lost to enemy action despite 125 sorties flown by Japanese interceptors. Japanese air defense commanders studied the engagement with growing concern. Their fighters had flown aggressively, pressing attacks despite the B-29's formidable defensive armament. But the bombers' speed, altitude, capability, and coordinated defensive fire made effective interception extremely difficult. Japanese pilots reported that the B-29 seconds cruised at speeds approaching 300 miles per hour at altitudes where many Japanese fighters lost performance. The remote gun turrets tracked multiple targets simultaneously, delivering concentrated fire that forced attacking fighters to break off before reaching optimal firing positions. More troubling was the raid's strategic implication. If American forces could mount 100 aircraft raids from the Marianas while simultaneously maintaining operations from China and India, they might have deployed more B-29 seconds than Japanese intelligence had estimated. But even the revised calculations produced during late 1944 suggested American strength might reach 400 to 500 aircraft at most. The concept that production could exceed 1,000 bombers simply fell outside the framework that Japanese industrial experience provided for analysis. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. Major General Curtis LeMay arrived in the Marianas during January 1945 to replace Hansel as commander of XXI Bomber Command. LeMay had led B-17 operations over Europe and B-29 missions from China, developing tactical innovations that improved bombing accuracy and reduced losses. But he inherited a command facing frustrating operational results despite growing strength. High-altitude precision bombing produced minimal damage due to persistent weather problems over Japanese cities and the jet stream winds at 30,000 feet that scattered bomb patterns across target areas. LeMay's solution represented a radical departure from established doctrine. On March 9 to 10, 1945, he ordered a low-level night incendiary attack on Tokyo, using 325 B-29 seconds, stripped of most defensive armament, to increase bomb loads. The aircraft would attack individually rather than in formation, approaching the target at altitudes between 5,000 and 8,000 feet to improve bombing accuracy and avoid the jet stream. The raid produced results beyond anything achieved in previous bombing campaigns anywhere in the world. The B-29 seconds dropped over 1,600 tons of incendiary bombs into a 15-square-mile area of central Tokyo, creating a firestorm that killed approximately 100,000 people and destroyed over 267,000 buildings. The devastation exceeded that caused by either atomic bomb that would later be dropped on Hiroshima or Nagasaki, demonstrating that conventional strategic bombing could achieve catastrophic effects when properly executed. Japanese air defenses proved almost completely ineffective against the low-level night attack. Only 14 B-29 seconds were lost, a casualty rate of roughly 4% that LeMay considered acceptable for the results achieved. The raid's success validated the tactical shift and established the pattern that XXI Bomber Command would follow for the remainder of the war. Mass incendiary attacks against Japanese urban areas conducted at night from medium altitudes. But the March 9th raid also revealed to Japanese military planners just how catastrophically they had underestimated American B-29 strength. 325 bombers participated in a single mission. That number alone exceeded the total B-29 force that Japanese intelligence had estimated America could deploy to the entire Pacific theater. and reconnaissance reports indicated that American airfields in the Marianas could accommodate many more aircraft than had participated in the Tokyo raid. Intelligence officers in Tokyo frantically attempted to reconcile observed American capabilities with their existing estimates. Perhaps the Americans had temporarily concentrated all available B-29 seconds for this single maximum effort mission. Perhaps aircraft had been transferred from China and India to the Marianas for the raid, but subsequent missions quickly eliminated these explanations. XXI Bomber Command launched major raids against Nagoya, Osaka, and Kobe throughout March, each involving 200 to 300 bombers. The operational tempo suggested a force much larger than 300 aircraft total. By April 1945, Japanese estimates grudgingly acknowledged that American B-29 strength in the Marianas might exceed 500 aircraft. This represented a significant upward revision from previous calculations, but still fell far short of reality. The 73rd Wing had been joined by the 313th Wing in December, the 314th Wing in January, and the 58th Wing in April. A fifth wing, the 315th, would arrive in June. Combined strength approached 800 combat-ready B-29 seconds by spring 1945, with additional aircraft in training or modification status. American production had reached levels that made the Japanese estimates seem quaint. By May 1945, Boeing's Wichita plant alone had delivered over 1,700 B-29 seconds. The combined output from all four production facilities exceeded 3,000 aircraft, with approximately 1,000 deployed to operational units in the Pacific and hundreds more in training or modification. The factories continued producing bombers at rates exceeding 100 per month, replacing combat losses and expanding the force simultaneously. The disparity in production capacity reflected fundamental differences in how the two nations approached industrial warfare. Japan had entered the conflict with approximately 75 B-29 equivalent heavy bombers total and possessed manufacturing capacity to produce perhaps 20 to 30 such aircraft per month under optimal conditions. Wartime attrition, material shortages, and damage from American submarine campaigns reduced actual production to negligible levels by 1945. American industry operated on entirely different principles. The B-29 program alone consumed resources equivalent to constructing hundreds of additional warships or thousands of tanks, but those resources came from an economy that produced more steel, aluminum, and machine tools than all other combatant nations combined. The United States could simultaneously build thousands of B-29 seconds while maintaining production of fighters, transports, and tactical bombers at rates that equipped not only American forces but Allied armies throughout Europe and Asia. The workforce assembling these aircraft represented another dimension of industrial mobilization that Japanese planners had failed to anticipate. Boeing's Wichita plant employed 15,000 workers at its peak. Bell's Marietta facility had 28,000. Martin's Omaha plant added another 14,000. Combined with Boeing's Renton facility and thousands of subcontractors producing engines, components, and systems, the B-29 program employed more people than Japan's entire aircraft industry. These workers produced aircraft at rates that seemed impossible by traditional manufacturing standards. A single B-29 required 12 tons of aluminum sheeting, 1,000 pounds of copper wiring, 600,000 rivets, 9 miles of electrical cable, and 2 miles of tubing. Assembling these components into a functional aircraft had initially required 157,000 man-hours. By mid-1945, Boeing had reduced this to under 20,000 man-hours through standardization, training, and continuous process improvement. June 1945 saw XXI Bomber Command intensify operations with raids involving 400 to 500 B-29 seconds, striking multiple targets simultaneously. On June 15th, 444 bombers attacked Osaka. Japanese fighters failed to mount any significant defense, highlighting the collapse of the air defense system under sustained pressure. By this point, Japan retained fewer than 300 operational fighters in the home islands, many lacking fuel for sustained operations and flown by pilots with minimal training. The B-29 offensive, had achieved what strategic bombing theorists had claimed was possible since the 1920s: reduction of an enemy nation's war-making capacity through air power alone. Japanese industrial production collapsed under the sustained bombing campaign. Steel mills, aircraft factories, and shipyards that had survived earlier raids were destroyed in follow-up attacks. Urban areas that provided housing for industrial workers burned in massive fires that displaced millions of civilians. Transportation networks that connected raw materials to factories and finished goods to military units were systematically dismantled. By July 1945, XXI Bomber Command operated over 1,000 B-29 seconds from bases in the Marianas. The 315th Wing, equipped with specialized B-29B models, stripped of defensive armament and optimized for night operations, joined the offensive in late June. This final wing focused specifically on oil refineries and petroleum storage facilities, using precision radar bombing techniques to destroy the remaining fuel supplies that Japanese forces required for any defensive operations. Japanese military planners confronted strategic options that ranged from desperate to hopeless. American bombers operated with virtual impunity over Japanese cities, encountering minimal fighter opposition and declining anti-aircraft fire as ammunition reserves were exhausted. The anticipated invasion of the home islands would be supported by air power that exceeded anything previously deployed in warfare. Intelligence estimates compiled during July suggested American air strength in the Pacific included over 1,500 heavy bombers, 2,000 medium bombers, and 6,000 fighters, with the capacity to increase these forces continuously through replacement and reinforcement. The atomic bombs dropped on Hiroshima and Nagasaki in August represented technological achievements that captured global attention, but the strategic bombing campaign, conducted by conventional B-29 forces, had already rendered Japan incapable of continued resistance. By August 6th, 50% of Tokyo had been reduced to rubble. 67 other cities had suffered similar devastation. Japanese industrial production had declined to approximately 10% of peak wartime output. Food distribution systems had collapsed, threatening mass starvation. The transportation network that connected the home islands to military forces overseas had been severed by naval blockade and aerial mining of harbors. Emperor Hirohito's surrender announcement on August 15th acknowledged Japan's inability to continue resistance against opponents whose industrial capacity had transformed warfare beyond recognition. The imperial military that had dominated East Asia for a decade possessed fewer than 1,000 operational aircraft, most immobilized by fuel shortages. American air forces operated thousands of aircraft with unlimited fuel, bombs, and replacement parts, treating sustained operations as routine rather than maximum effort events, requiring weeks of preparation. The final accounting of B-29 production revealed the extent to which Japanese intelligence had miscalculated American industrial capability. Total B-29 production reached 3,970 aircraft by the time contracts were terminated in September 1945. This figure exceeded Japanese estimates by more than 13-fold, representing not a marginal intelligence error, but a fundamental failure to comprehend how American industry approached warfare as an engineering problem to be solved through superior resources and organizational efficiency. Boeing's Wichita facility alone had produced 1,769 B-29 seconds, accounting for 44% of total production. Bell's Marietta plant contributed 668 aircraft, despite facing numerous technical challenges during startup. Martin's Omaha facility delivered 536 bombers. Boeing's Renton plant added over 1,100 more. Each facility had reduced production times, improved quality control, and increased output rates throughout the war, demonstrating continuous improvement that Japanese manufacturers could not match. The intelligence failure regarding B-29 production capacity stemmed from institutional blind spots that permeated Japanese military planning throughout the Pacific War. Major General Makoto Onodera, who served as military attaché in Stockholm during the war, later acknowledged that Japanese intelligence services had fundamentally misunderstood American industrial organization. They viewed manufacturing through the lens of their own experience, where quality, craftsmanship, and individual skill determined production rates. The concept that Americans would treat aircraft manufacturing as a mass production problem similar to automobile assembly fell outside their analytical framework. Japanese intelligence organizations entered the war chronically understaffed and institutionally undervalued. The Army General Staff's Second Bureau, responsible for analyzing foreign military capabilities, employed only 20 officers and 20 enlisted personnel focused on all foreign militaries at the war's outbreak. Their primary focus had been the Soviet Union, with just 2 or 3 officers addressing air intelligence. The Army War College provided minimal intelligence training, and military culture emphasized combat operations over analysis. Intelligence positions were often assigned to mediocre personnel rather than top officers, ensuring that the organization lacked both resources and institutional authority to challenge operational assumptions. This weakness proved catastrophic when Japan needed comprehensive analysis of American industrial mobilization. Intelligence officers could track American ship construction with reasonable accuracy because naval vessels were built in coastal yards, visible to reconnaissance, and reported in naval publications. Aircraft production occurred at inland facilities that Japanese reconnaissance could never observe, leaving analysts dependent on fragmentary information from signals intelligence and prisoner interrogations. The estimates they produced reflected what seemed possible based on Japanese industrial experience rather than what American industry could actually achieve. Cultural factors compounded these analytical failures. Japanese military culture during this period did not reward officers who delivered unwelcome assessments. The emphasis was on fighting spirit, tactical excellence, and offensive operations. Suggesting that the enemy was far stronger than estimated was seen as defeatist. Intelligence that contradicted operational planning was often dismissed or ignored, creating an environment where comfortable assumptions persisted despite mounting evidence to the contrary. The first concrete indication that something was fundamentally wrong with B-29 estimates came not from intelligence analysis, but from operational observations. When XXI Bomber Command launched raids involving 300 to 400 aircraft during March and April 1945, Japanese air defense commanders realized they faced forces much larger than anticipated. But even these revised estimates significantly underestimated actual American strength. Japanese intelligence suggested American B-29 forces in the Marianas might number 500 to 600 aircraft by mid-1945. The actual strength exceeded 1,000 bombers by June. Part of this persistent underestimation reflected Japanese inability to comprehend American training and replacement systems. Traditional Japanese military aviation built strength through careful cultivation of elite units over years of preparation. Pilots underwent extensive training programs. Ground crews developed expertise through long apprenticeships. Units drilled constantly to achieve precision. When aircraft or personnel were lost in combat, replacement required months or years because the entire system was built for quality rather than quantity. American forces operated on opposite principles. They decided that scale mattered more than individual perfection. Training systems could process thousands of pilots through compressed curricula that emphasized standardized procedures over individual artistry. Ground crews learned to maintain aircraft using documented technical manuals rather than relying on accumulated experience. When B-29 seconds were lost in combat or accidents, replacement aircraft arrived from factories within weeks, often with improved components and systems that incorporated lessons learned from operational experience. This industrial approach to warfare meant that American strength grew continuously rather than declining through attrition. Each month's production exceeded the previous month's losses, creating exponential expansion that Japanese forces could not counter regardless of tactical skill or individual courage. A B-29, shot down over Tokyo in March, would be replaced by 2 aircraft, arriving from production lines in April. The crew would be replaced by graduates from training programs that operated on schedules synchronized with aircraft delivery rates. Japanese manufacturers struggled to replace even a fraction of combat losses. Aircraft production peaked at approximately 28,000 planes in 1944, but this figure included trainers and reconnaissance aircraft alongside combat types. Heavy bomber production remained negligible throughout the war. By 1945, American strategic bombing and submarine campaigns had severed raw material supply lines, forcing Japanese factories to reduce output despite increasing demand for replacement aircraft. The B-29 program's success reflected organizational innovations that Japanese industry could not replicate. Boeing had pioneered the use of statistical process control to identify and eliminate manufacturing defects before they reached final assembly. Instead of inspecting completed aircraft and reworking problems, Boeing tracked defect rates at each production stage and modified processes to prevent errors from occurring. This approach reduced rework, accelerated production schedules, and improved overall quality despite using workers with minimal experience. Standardization extended beyond the aircraft themselves to encompass the entire supply chain. Engine manufacturers delivered R3000, 350 units that met identical specifications, regardless of which vendor produced them. Propeller manufacturers supplied blades to standardized mounting interfaces. Instrument suppliers provided gauges calibrated to standard ranges. This interchangeability meant that any component could be installed on any aircraft without custom fitting, eliminating the bottlenecks that traditional manufacturing encountered when parts from different suppliers required individual adjustment. The logistics system supporting B-29 operations demonstrated similar industrial thinking applied to military supply chains. Each bomb group in the Marianas required specific quantities of fuel, bombs, spare parts, and technical support calculated based on operational tempo and mission profiles. Supply ships delivered these materials on schedules coordinated with bombing campaigns, ensuring that raids could continue without interruption. When a B-29 required engine replacement, ground crews installed a new power plant in hours rather than days, because standardized mounting systems and documented procedures eliminated the need for individual engineering judgment. Japanese forces defending the home islands possessed no equivalent logistics infrastructure. Fuel shortages kept fighters grounded for weeks between missions. Spare parts became unavailable as factories producing them were destroyed or cut off from raw materials. Ammunition stocks dwindled because transportation networks connecting arsenals to defensive positions had been severed by bombing and naval blockade. Even when Japanese pilots possessed the skill and courage to engage B-29 formations, they often lacked fuel for sustained operations or ammunition for extended combat. The strategic implications of this industrial disparity became undeniable during the summer of 1945. XXI Bomber Command launched over 5,000 individual sorties during July, dropping approximately 40,000 tons of bombs on Japanese targets. This single month's effort exceeded the total tonnage dropped by all Japanese aircraft throughout the entire war. The operational tempo demonstrated capabilities that Japanese military planners found incomprehensible. How could American forces sustain such intensive operations continuously for months without apparent degradation of readiness or effectiveness? Up next, you've got two more standout stories, right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out. And don't forget to subscribe and turn on the notification bell so you don't miss any upload from us.